Hello, this is Mr. Huber. In this lesson, we're going to work on solving two-step equations. So the equation solving process we want to follow is as such. We want to simplify both sides of the equation separately from one another. Before we look at doing anything to both sides and using inverse operations, think of that equal sign like grouping the left side and right side of our equation separately. Then we want to simplify the left side, simplify the right side, and then we can work on getting the variable on just one side and use our inverse operations. Okay, so first, simplify both sides of the equation. Then, when we have to work between the two sides, we want to get the variable on just one side of the equation as our next step, and then isolate the variable using the reverse order of operations. Remember, we're going to use inverses that undo each other. So when we want to move things from one side of the equal sign to the other, we have to use those inverse operations to cancel them out and do the same thing on both sides. Remember to keep the equation balanced. Okay, we want to keep the equation balanced by doing those same inverse operations on both sides of the equal sign. So first simplify on each side separately. Then when we look between the two sides, get the variable on just one side. If we want to know what x equals, we have to have an x or whatever the variable is by itself on one side of the equal sign. And then to get the variable by itself, we're going to use the reverse order of operations. Order of operations says we multiply and divide, then add and subtract, and we're trying to evaluate. Well, now when we're doing inverses to solve an equation, we want to take care of addition or subtraction, undoing each other first, then multiplication or division. And finally, remember to check your solution. Always important to check your solution, no matter how many steps, no matter what the equation looks like. So we're going to try some examples here. Okay, so we have 4y minus 4 equals 16. So first we want to look to simplify each side of the equation. So if I look here, there's nothing I can simplify. These are not like terms. I can't add and subtract something with a variable and something without. So both sides of the equal sign are simplified. Now I want to make sure the variable is only on one side of the equal sign. So I only have a variable on the left side. That's good. Now I want to isolate that variable. I want to get the variable by itself by using inverse operations to undo each other and reversing that order of operations. So I want to look over here where the variable is, and I want to do any addition or subtraction inverses first. So I have a minus 4. So my first step is going to be to add 4 to both sides of the equal sign. That will cancel out and give me 4y equals 20. Then I want to divide by 4 because I want to cancel out the multiplying by 4. 4 times y, the inverse of that is dividing. So 4 divided by 4 is 1y equals 5. And I can check that by taking the 5 and plugging it back in. And I will get 4 times 5 minus 4. That's 20 minus 4. That's 16 equals 16. That checks out. And I know y equals 5 was my correct solution. Let's try the next one. 7x minus 4x equals 21. So the first thing I'm going to do is simplify this side of the equal sign. 7x minus 4x. Those can be combined together to give me 3x equals 21. Okay. What you don't want to do, you don't want to say, oh, I'm going to add 4x and then add 4x. Okay. If you add 4x here to cancel this out, you need to add 4x on the other side of the equal sign. When you're doing inverse operations, you should be doing the same thing on both sides of the equal sign, not twice on the same side of the equal sign. That's a common mistake. Don't add 4x and then add 4x again twice on the same side of the equal sign. So here I can combine these and simplify that side of the equal sign. And now that I've got the variable just on one side of the equal sign, simplified, I can use my inverse operations to undo the 3x equals 21. That would be divide by 3 on both sides and give me x equals 7. And I can check that by plugging into my original equation. 7 times 7 minus 4 times 7 equals 21. That's 49 minus 28 equals 21, and I get 21 equals 21. That checks out, so x equals 7 is a correct solution. Now let's try this third problem. Again, you can be trying these on your own as well and seeing how you're doing on them. So in this instance, we have the z just on the right side of the equal sign. There's nothing to simplify, no like terms to add or subtract. So I can use my inverse operations to add 7 on both sides, cancel out the minus 7. On the left side, right, it's the same thing on both sides of the equal sign. Negative 1 plus 7 is 6 equals z over 3. Z over 3 is z divided by 3. So how do I cancel out? I multiply by 3, right? I multiply by 3 on both sides because that's like 3 over 1. Those cancel out. and that would give me just z by itself, and 3 times 6 is 18. Now what should I do? I should check that answer. So I'm going to check that by plugging it in my original equation. Negative 1 equals 18 over 3 minus 7. It's negative 1 equals 18 over 3 is 6 minus 7. Negative 1 equals negative 1. That checks out, and I know I have a correct solution. Always check. Does my answer make sense? When you're solving equations, plug it in. If it works, then that's a good sign that it makes sense. As we try some more equations here in solving, you should be trying these and seeing how you do on your own, and then playing the video to see how you've done. In this first equation, number 4, we're going to subtract 9 on both sides. Right? Then we have negative 6m equals negative 48. Then I can divide by negative 6 on both sides. Keep track of those negative signs. That's going to be a positive 8. And I can check that. Negative 6 times 8 plus 9 equals negative 39. That's negative 48 plus 9, which is negative 39, equals negative 39. That checks out. 8 is my correct solution. The next equation, I have a variable on both sides, so I need to make sure that I get the variable just on one side of the equal sign. I can do that by canceling out the 3y on the right side, doing the same thing, inverse operation on the left side. Keep in mind, this is a balance, right? We have our equation, we want to keep it balanced. When you do an inverse operation, you do the same thing on both sides. That's not the same as combining, adding, subtracting like terms. When we're canceling something out with an inverse operation. So we're going to get 5y equals 20. Then I can divide by 5 on both sides and get y equals 4. I can substitute that back in. 8 times 4 equals 3 times 4 plus 20. That's 32 equals 32. That checks out, and I know my answer's correct. One more problem here, number 6. Before we move on, we've got 5d minus 9d on the right side. We are not going to do minus 5d and minus 5d to cancel that out, because now I've subtracted 5d twice on the same side of the equal sign. Okay, I don't want to subtract it twice on the same side of the equal sign. I'd have to go over here and do minus 5d. That's not what I want to do. So don't do that. We're not going to use an inverse operation. We have them on the same side of the equal sign. We're just going to combine our like terms. We have negative 16 equals negative 4d. Divide by negative 4. Divide by negative 4. We get positive 4 equals d. We can plug it back in. We'd find that it works. Right. Before we see some other examples of little different situations, a beautiful break. What do you think is the geographic center of the 50 United States? See if you can even figure out what state it's in. It's in South Dakota. Belforge, South Dakota, is the geographic center, and that became true in 1959 when Alaska and Hawaii were added to the Union. Before that, it was in Kansas. But when you added Hawaii and Alaska, it moved that center a little west and a little north from Kansas to South Dakota. So in South Dakota is the geographic center of all 50 United States. In these examples, we're going to write out an equation and then solve it. Okay, so it's a little different. We're going to use some skills we know for how to write out an expression, in this case an equation, and then we're going to be able to solve the equation that we write. So we're going to look here. The output of a function is 3 less than 5 times the input. So we're just going to start there. Forget this next part. First, we're just going to write out the equation. Okay, our equal sign, right, that's our equal sign. Okay, and then it says the output. Okay, so the output we're going to use as our y. So y equals 3 less than 5 times the input. I'm going to use x for the input. It doesn't really matter what variables you use. I'm going to use x and y. Okay, 3 less than 5 times the input. So 5 times the input and 3 less. It's not 3 minus 5x. It's 5x minus 3. That's going to change things when we go to solve if you write that in the wrong order, right? 3 less than something means you're taking the 3 away. So now I want to find the input when the output is 16. So if the output is 16, that means I can substitute that in for the output, for the y. So I'm going to figure out what happens when my output's 16. What is the x value? The input. Okay. So now I can add 3 to both sides. I get 19 equals 5x. And then I can divide by 5. And x equals 19 over 5. You can leave it like that. We could turn it into a mixed number, 3 4/5. You can make it 3.8. Okay, unless the directions specify some certain type of answer, 19 over 5 would be sufficient. Okay, so write out the equation, find that is, write each side separately. Keep in mind what those key words mean, like less than, okay? 5 times the input, right? We're multiplying. So then we have an equation we can solve. And make sure we're plugging in. If it said the input was 16, we put a 16 in for the x. Here it says the output is 16, so we need to put that in place of the output, in this case the y value we used. Here's another one. Again, you should be maybe trying this one out on your own and then play the video and see how you do. The output of function is 5 more than negative 2 times the input. So let's see what that would look like. So the output, again I'll use y, is 5 more. So I'm adding 5 onto something. Negative 2 times the input. Negative 2 times the input. Right? When we have multiplication of a number and a variable, just write them directly next to each other. Right? This indicates we're multiplying the negative 2 and the x. So now we're going to put an output of 11. So we're going to take 11 and place it in for the y, negative 2x plus 5. And we can solve this. Subtract 5 on both sides. 6 equals negative 2x. Divide by negative 2. And we get negative 3 equals x. Right, so that's our input. We could check that. We could put a negative 3 back in. Right? We could say, okay, put negative 3 in there. Negative 2 times the input. So negative 2 times negative 3 is 6. 5 more than that would be 11. Yep, that's our output of 11. Right? So we can check and make sure that it makes sense. An application type problem here. Okay, about scuba diving. Scuba diver descends into deep water, and as you do that, the pressure of the water builds. Okay, it increases. So we're given some information here. The pressure at the surface of the water is 2,117 pounds. So pressure at the surface of the water is 2,117 pounds per square foot. Okay. Then we got the pressure increases at a rate of 64 pounds per square foot. So increases at a 64 pounds per square foot for each foot the diver descends. Find the depth at which a diver experiences a pressure of 8,517 pounds. We have a formula here given. Okay, so we're going to use this formula. The pressure at any depth is equal to the pressure at the surface plus the rate of change times the depth. Right? So we're going to add. As a diver goes deeper, we're going to add more pressure. So the pressure at a given depth. So the pressure, 8,517 pounds per square foot. We're trying to find the depth. We're trying to find this. The divers, not drivers, don't drive deep into the ocean. The diver's depth, that's what we're trying to find. Okay? I'm going to call that our x. So now when I write the equation, I'm going to have the pressure at the given depth. So the pressure is 8,517 equals, okay, pressure at the surface. Well, we found pressure at the surface. That's 2,117. 2,117 plus the rate of change. The rate of change is 64 pounds per square foot for each x, right? Each foot the diver descends. So now I have an equation I could solve, right? I put in the pressure equals the pressure at the surface plus the rate at which it's increasing for every foot. Now I can solve this for the x. I have an equation that I've written out. Anytime you have an equation with one variable, you can solve it. So I'm going to subtract 2,117. Okay, so I'm going to have 8,517 minus 2,117. That's going to give me 6,400 equals 64x, and then I can divide both sides by 64. Okay, so I divide by 64. Divide by 64 again. I'm using the same process I did at the first equations. I didn't have anything to simplify. I had the variable on one side, so now I'm using my inverse operations to cancel out using the reverse order of operations. And so now this is going to give me x equals 100, and that would be feet. So the diver would be 100 feet below the surface of the water for the pressure to get to 8,517 pounds per square foot. All right, so solving some equations with more than one step. Remember that process. Simplify, get the variable in one location, and use inverse operations the same on both sides. Keep it balanced. Whatever you do an inverse operation to cancel out, it needs to be done on both sides of the equal sign. Get that variable by itself. And remember, reverse order of operations. Take care of any addition or subtraction, and then multiplication or division to cancel out and get that variable isolated. And always remember to check your answers.